I'm starting a series of standalone projects that will eventually come together as a escape in a box kind of puzzle game. It's called SpaceCadet. I plan for each episode to be a bite-sized build that can also be easily replicated. In this first episode, a vertical scroll dodging game played with a physical spaceship that you slide with your hand. The display is for 8x8 LED matrices stacked vertically, so you get a tall and narrow screen, 8 columns wide, 32 rows tall. The ship is static and the rest of the game scrolls down. Asteroids come from the top and you have to slide it left or right to dodge. Score counts how many asteroids you manage to avoid. This is gonna be the controller for the game. It's a 3D printed miniature, a spaceship, with a magnet embedded in the base that will fit inside the track. The position sensing has to be wireless. The ship has to glide freely over the terrain. This is also important because in the finished game, the players will only receive this at a certain moment, so they won't be able to play before. I mentioned magnet because that's what the sensors will read, but before I got there, I actually tried linear fader. I happen to have one of these and it was almost perfectly the same width as the matrix. So I figured that's a sign. It wasn't. A significant chunk at one end of the travel was outside the usable resistance range, effectively a dead zone. There was also a gap at the other end, and the middle section was non-linear, which I could have corrected in software, but the dead zones were a deal breaker. The track definitely needed full coverage end to end. The solution was 2 Hall effect sensors, one on each end. One sensor alone doesn't have the sensitivity to detect magnets across the full run, but with 2 the analog outputs actually complement each other. I'm summing them, which partially cancels out the individual non-linearity. Well, partially, there's still some non-linearity in the combined signal, so I built a small lookup table in firmware to map ADC values to the 8 columns positions. Quickly measured by hand, job done. I got an upgrade for the spaceship figurine using the services of today's sponsor, PCBWay. They are best known for democratizing custom PCBs, but they offer a full prototyping stack. CNC sheet metal 3D printing across multiple technologies. I used the resin printing for the new spaceship figurine, but the extra cool bit on this one is the electroplating finish. Ever since the electroplated 3D printing exploded on YouTube, I've been FOMOing hard, never quite having a good enough reason to start DIYing it. Turns out I can just order it. Thank you, PCBWay. This is the glossy silver, I'd call it chrome if you ask me. They also have matte and several other colors. Go check it out on PCBWay.com. The link is also in the description. For the microcontroller, I picked the Lolin S2 Mini with GPIO headroom in mind for when this gets integrated into the puzzle box. The firmware, asteroid with randomized speed and spawning timing, collision detection against the ship footprint, and the large bitmap font for displaying the score. The explosion animation is like a shockwave. I'm pretty happy with how this turned out. You'll find the GitHub link in the description or the pinned comment. It's now time for a proper enclosure that would hide and diffuse the LEDs a bit, and also integrate the channel or the track for the ship controller. It's designed to eventually mount flush on the face of the puzzle box, but I also built a back cover for anyone who might want this as a standalone minigame. I think I know a guy already. The board with the 4 matrices slide in from the top, and the Hall sensors need a little gentle pressure, not too much. Oh, don't forget to somehow insulate the middle pin, unlike me here. This is the wiring diagram for my S2 Mini, but it's pretty easy to adopt to another microcontroller too. There's also a bill of materials or shopping list in the description or the pinned comment. I'm trying out affiliated links for the first time. You might use those if you like. The back enclosure features a pocket for the TP4056 single cell charger, and a small anchor point for fixing the cell with a zip tie, whatever the size and shape. This is it for the episode. The minigame is fun to play, I'll tell you that. Right now I have 2 more episodes for this series in progress and another bigger project coming up. So subscribe and stick around our little community here. Catch you in the next one. Catch you in the next one. Luckiest run ever. I didn't move.